First of all, I am going to discuss distance and displacement, right?
Yeah.
Distance and displacement. This is our first topic, right?
Yeah.
Distance
Or
and
distance and displacement. I thought it's velocity and acceleration.
yes, yes. Then after I will discuss the speed and velocity, and then after acceleration, and then after motion along a straight line with constant acceleration, and then after I will discuss this topic. For instance, this topic, such as this one,
Okay.
right?
Okay. Yeah.
Distance and displacement. The actual path followed, the actual path followed, followed by the particle during its motion, during its motion is called distance, is called distance. For instance, say this is y-axis, this is x-axis, and any particle moves in such a way that it follows the path like this, right?
Yeah.
Point O, A, B, C, D. Point O, A, B, C, D. Right? Then
Yeah.
length, length O, A, B, C, D is called is called distance. Is called distance. Right? This
Yeah.
length, this length is called distance. And distance is a scalar quantity. Distance is a scalar quantity, and its unit is in meter. Its unit is meter. And the distance cannot be negative. Very important. Distance cannot be negative. Distance cannot be negative. Distance cannot be negative. Any problem?
No.
Very good. And again, what is displacement? What is displacement? Displacement. Answer of this question is change in position vector. Change in position vector of particle. Change in position vector of particle during its motion. During its motion, during its motion is called displacement. Displacement. For example, suppose an insect moves in xy plane, looking like this, right?
Yeah.
So this length, I am saying this length, sorry, this length, this length, right?
Yeah.
Say this is point A, this is point B. The quantity AB, the quantity AB is called as displacement. Is called as displacement. Quantity AB is called displacement, and this was initial position vector. This was initial position vector. Say you can say R initial, and this was final position vector. You can say R final, and you can write suppose OA vector plus AB vector will be equal to OB vector. This is called as triangle rule. This is
Triangle
called
rule.
as
Okay.
triangle rule of vector addition. Vector addition. and this is called R initial plus AB plus AB, and this is called R final, right? So AB vector will be equal to R final vector minus R initial vector, and this is called as AB vector will be equal to delta R vector, right? And this quantity is
Yeah.
called displacement vector. Displacement, displacement vector. Any problem?
No, no.
Very good. You can tell me any question if you face, right?
Okay.
So this was distance whole length. This was distance green circle, green part, and yellow part A to B is called displacement, right?
Yeah.
You can also write minimum distance is called displacement. This is also a correct statement. Minimum distance, minimum distance, minimum distance is called minimum distance is called displacement. Minimum distance is called displacement. And one more thing, displacement can be negative, can be zero, and can be positive. But distance is always either zero or positive. This cannot be negative, right?
Okay. Yeah.
And now displacement displacement may be negative, may be negative, positive, positive, or even zero, or even zero. But distance, but distance cannot be negative.
But it
Cannot
can be zero, right? Yeah.
cannot be negative. Tell me
It can
again.
be zero, right, sir?
Hello, please tell me again.
It can be zero, right?
I could not hear.
It can be zero, right?
It can be zero. Yes. Minimum value, minimum minimum value of distance is zero. No problem. Is zero. Right. This is,
Yeah.
and displacement is a vector quantity. Displacement, unit of displacement is meter. Unit of displacement is meter. Unit of displacement is meter, and this is this is a vector quantity. Vector quantity. I have an example. Suppose uh, this is a circle, right?
Yeah.
And there are two persons, A and B. One follows like path this, 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 and again this, right?
Yeah.
This is the path followed by A. Single arrow is the path followed by A. Radius is R. Radius of circle is R. Single arrow path followed by person A. Path followed by person A. Right? And suppose person B follows a path like this. The path followed by B is suppose here to here directly, right? And then
Yeah.
directly, and then here directly, and then come back to center, right? This is
Yes.
double arrow is path followed by B. Path followed path followed by person B. By person B. path followed by person A, path followed by person B. Tell me, distance, distance and displacement, distance and displacement for A and for B, for A and for B.
So what's the radius?
Radius is R. Radius is R.
Okay. Um, so it should be for A, the distance.
Distance is how much?
Wait, where did A
For
start from? Is it the
yes,
top?
this is starting point, and
Okay, okay.
center is terminating point.
So it went all the way around?
No, no, no. First of all, here,
Okay.
first of all, point, say this is point one, this is point two, this is point three, and this is point four. For
Okay.
A, for A, for A, this
So
is
it's
one to
pi
two,
r plus r.
two to three, and three to four. This is
The distance is pi r plus r.
excellent, very good. Pi are
Displacement should just be r.
just R, very good,
Displacement for B is also just r.
very
And
good.
then the path followed by B. Okay, if we see what this is. 1 second, sir.
Oh, no, no issue, no issue.
Okay, so it should be square root of y squared plus r squared. It should be times 3. 3r root 2 plus r.
Yes, very good. R to three times plus R, right?
Yeah.
Excellent. Now I am going to discuss velocity and speed.
Okay.
Can I change the space?
Yeah, yeah, no problem.
Okay. And I will send PDF of this, right?
Yeah.
Now discussing about distance and speed. Sorry, a speed and velocity. A speed and velocity. A speed and velocity. A speed. A speed average is defined as V average equals to total distance traveled, total distance traveled, total distance traveled by total time taken, by total, right? This
Yeah.
this is called as V average. A speed average is defined as this, and a speed instantaneous is defined as a speed a speed instantaneous. A speed instantaneous is defined as V instantaneous will be equal to total distance traveled by total time taken provided limit delta t tends to 0. Limit delta t tends to 0 limit delta t tends to 0 means delta t, or you can say time interval should be very small. Time interval time interval should be time interval should be very small. Time interval should be very small, right?
Yeah.
I think this tends to 0. Delta t, I mean delta t, t2 minus t1. I think t5 minus t initial tends to 0, tends to 0, right? This is
Yes.
time interval should be very small. T5 minus T initial tends to 0. Okay.
Wait. T. Uh, can you show me what the bottom one means? Like before tends to zero. I don't know what that
Yeah,
means.
yeah, I am describing it just for just 1 minute.
Okay.
Suppose
No, I mean like what variables are they? I can't make it out.
this is y-axis, so sorry. This is say this is s and this is time. Okay,
Okay.
and this is a graph like this s as a function of time, right?
Yep.
And say this is t initial and this is t final. This is t final, right? This
Okay.
point connecting between them is chord, right?
Yeah.
Suppose this is suppose this angle is theta and this is say point A, this point as B and this point as C, right? This angle is
Yeah.
90 and you can write tan theta equals to perpendicular by base and you can write perpendicular as delta S. Any problem? And AB
No
as
problem.
delta T.
Yeah. Yeah.
AB as delta T. You can write delta T as T final minus T initial. You can write delta T as T final minus T initial. Right?
Okay. Yep.
This quantity, try to understand carefully. This quantity tan theta, slope of chord, slope of chord, slope of chord is called a speed average. Is called a speed average. Clear? Not clear.
I think that. Wait. One second.
This is
So
tan.
that.
Just a,
Okay. Okay.
just a
Yeah. Yeah.
second.
That's clear. That's
This
clear.
is this
Understood.
is
Understood.
tan theta, and this
Because
is tan theta equals to perpendicular by base, and this will be equal to this length will be just s delta s, right?
yeah.
I think this is s final, and this is s initial. You can write
So
this.
because the speed is changing on the curve, that chord is basically the average of those speeds.
Excellent, exactly.
Okay. Understood.
This length is called delta s. This is S final, this is S initial, and this is delta S. That's why this is delta S and this is delta T. Right? And
Yeah.
tan theta equals to BC upon AB, and so BC equals to del S and AB equals to del T, and delta is this is T final, this is T initial, and this length must should be equal to delta T, that will be T final minus T initial. And in ST curve, in distance time curve, very important, in distance time curve, in distance versus time curve, slope of chord, slope of chord, slope of chord represents, slope of chord represents average speed, average speed, right?
So, this is just like kind of a guess, but is the reason that the limit of delta t tends to zero is because the
Coming,
bigger
coming,
delta t is,
coming
the
there,
less accurate the average is?
coming there. Just wait 1 minute, right?
Oh.
Can change this page? Can I change this page?
One second. I'm just. Yes. Okay. Yeah, I got it.
Okay. Now I am going to describe this part. What is V instantaneous, right?
Yeah.
This was V average. This was V average. Uh, and at last, tan theta equal to V average equal to del S upon delta T. That is del S upon T final minus T initial. This is time interval, not instant. This is interval.
Okay.
Again, in this part. Again in this part, say suppose this is S and this is D, and say this like this. Suppose there are 2 points, say A and B, A and B,
Yeah.
and let any particle is just starting to move from point B towards point A along the curve. Suppose suppose any point B, suppose any point B, suppose any particle, suppose any particle uh, has started to move from the point B, from the point B towards the point A, towards the point A along the curve, along the curve, right? Say initially particle was at point B, and then after here, then after here, and then after here, very close. So
Okay.
this was chord, this was still chord, but this is looking like a tangent, right?
Yes.
Say this is point B1, this is point B2, this point B3, then I am able to say AB is chord, AB1 is still chord, and AB2 is still chord, and finally AB3, not looking like a chord, looks like a
Like
tangent,
a okay.
looks like a tangent. Clear?
Okay, so that's why as you go smaller and smaller, it's
Yes,
practically attached.
exactly, Muhammad, exactly. This time is very small time. This delta t approximately tends to zero. Approximately, tends to zero. Not exactly. Tends to zero. Not exactly, right?
Yes.
Not exactly, right? This time,
Yeah.
and that's why I wrote that moment delta x upon delta t. But limit confinement is delta t tends to zero. This is called V instantaneous. That means at a particular moment, velocity of this particle is this, right?
Yeah.
Velocity of this particle at particular moment, this moment at point. So V instantaneous equals to del x upon delta limit delta t tends to zero, and normal V or V instantaneous equals to this quantity is called dx by dt, right? The
Okay.
quantity delta x upon delta t satisfying limit delta t tends to zero is known as dx by dt, right? And please try to understand one more thing is that
I'm not really sure about dx by dt. I don't know where the x came from.
no, this is time interval, and if we put delta t tend to zero, this will be very small. You can write in the differentiable form dx by dt. This is the this is the geometrical interpretation of dx upon dt. This means how x changes with respect to time, how x changes with respect to time, this means, and this is slope of
And
tangent.
x is kind of distance.
Yes, how s changes with respect to time. S means here you can write s, no issue.
Oh, okay. Okay, yeah, this makes sense. Yeah.
And just one more thing I have to say. Say say this. This is tangent. This is tangent, right? And this angle, you can imagine this angle as beta, right? So this angle is beta. What can you think about this angle? This is S, this is T. What is tan beta? Tan beta, first of all, I have to say slope of tangent, not chord. Slope of tangent.
Okay.
Any problem, Mohammed?
No.
Excellent. This is slope of tangent, and this will be equal to this same thing, del S upon del T, limit, limit delta tend to 0. We can also write as ds by dt, ds by dt, and we can also write this as v instantaneous, right?
Yes.
So
Okay.
overall, tan beta equals to v instantaneous. You can write general v, I mean general speed, and this will equal to ds by dt. And what is the geometrical meaning of ds by dt? In we can write how s changes, how s changes, how s changes with respect to time, with respect to time. And I got this angle at this point, this particular time. Say you can write this time as t, or say t dash, right? So v instantaneous is the value of any particle that is moving at particular time t dash, not interval. In this segment, we have to say interval in case of V average, not V instantaneous. In case of V instantaneous, that is a particular instant of time. Right?
Okay.
Any problem?
No.
Excellent. This was a speed. This was a speed. Right? This
Yeah.
was a speed, not velocity. Now I am describing about velocity. Do you know something about velocity, Mohammed?
Yeah. So velocity is vector quantity, so it has both speed. It has a magnitude and direction.
Okay. And simple definition of velocity is, what is velocity? And this is the rate of change of position. The rate of change of position. The rate of change of position. The rate of change of position is called, the rate of change of position is called velocity. The rate of change of position is called velocity. This is velocity, right? And
Yep.
velocity average is defined as, velocity average velocity average is defined as r final, r initial by t final minus t initial. This is displacement. This is displacement, and this is time interval, and this is time interval.
Okay.
This is displacement, and this is time interval, right? And
Yeah.
similarly, on the same basis, similarly, similarly, velocity instantaneous, velocity instantaneous is defined as, is defined as uh, delta r upon delta t,
Oh, okay.
limit delta t tends to 0, right? That's why this equals to dr by dt. So
Okay.
velocity or velocity instantaneous will be equal to dr by dt. And I have written formula. The rate of change of position is called velocity, and the quantity dr by dt is called that, the rate of change of position. The rate of change of position.
Wait. So R is displacement, or
No, no. R is, you can write this as displacement. Whole this term is displacement. This term, right?
like, but in physics, D is distance and S is displacement, right?
No, no, no. dr upon dt means in physics. What do you mean by dr by dt?
I'm just asking about the symbol, sir. Like t is time, so v is velocity, s is speed. Oh wait, no. So is this? We were taught that d is distance and s is
No, no,
displacement.
no, no. I am describing in brief dr by dt. Try to understand. Suppose delta r by delta t. This means change in r. This means change in r, change in time, change in time. In physics book, this is written as delta r upon delta t. This is change in r final minus r initial by t final minus t initial, right?
Yes.
But dr validity means, very, 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 very small change in r. Very, very small change in r, change in r, and dt is very, very small change in time. And dt is very, 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 very small change in time. Small change in time. Right?
Yeah.
Any problem?
No.
This is very, very small change in r and very, very small change in time. Right? This is the meaning of dr. Clear?
Okay.
And that's why delta r upon delta t, if limit delta t tends to 0, very, very small, very, very, very small interval of time. This is called dr by dt. Right? This is.
Okay.
So this was a dr upon dt is the rate of change of position. Right? And this was displacement by time interval. And this is not just like displacement by time. This is differentiation. This is
Yeah.
differentiation of position vector. This is differentiation of the position vector with respect to
One
time.
second, sir. Someone rang my doorbell.
Understood? Yes or no?
Yeah, I'm back, sir.
Did you understand this? dr upon dt means differentiation of the position vector with respect to time.
Differentiate. Yes, yes, I understood that. Yeah.
Okay. Now I have to describe one more thing, that is acceleration. Okay.
Okay.
Can I change this page?
Yeah.
Now I have acceleration. 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 First of all, definition of acceleration: the rate of change of velocity is called, yes or no?
Yeah.
The
Okay.
rate of change of velocity is called acceleration.
So dv by dt.
Yeah, yeah. On the same basis, acceleration acceleration is a vector quantity. Acceleration is a vector quantity, and its SI unit, and its SI unit is acceleration is a vector quantity, and its SI unit is meter per second square. Acceleration has two types as usual. Acceleration average. Acceleration average is defined as A average will be equal to V final minus V initial by T final minus T initial, right?
Yeah.
And this is called as delta V upon delta T. And acceleration acceleration instantaneous is defined as A instantaneous is an A instantaneous equals to dv upon dt, or you may write this as say delta v upon delta t, but limit limit delta t tends to 0. That's why
And then you get dv by dt. Okay.
EI,
Yeah.
right?
Yeah.
This was acceleration. Did you understand all things?
Yes, I understood. Yeah.
Okay. And I have a question based on these topics, and I am asking you that question. Please try to solve. Otherwise, I will solve that question.
Okay. Oh, 1 second, sir. I'll just finish writing this down then.
Okay. Question is
Okay.
now I have a question. The distance traveled by a particle in time t is given by 2.5 meter per second square t square. First question is the average speed. Find the average speed find the average speed of the particle during the time t equals to 0 to t equals to 5 second. And B part is just a second, Mohammed, just a second. My battery had discharged completely. Just a second.
Okay.
Yeah. And B part is Just a second. The instantaneous speed, the instantaneous speed at t equals to 5.0 second, right?
Okay.
Can you do this?
Okay, one second.
Okay, very good. Please try to solve this.
Okay. So for A, it should be 12.5?
2.5.
12.5, 12.5.
Just a second. Question was find the average speed of the particle. The answer of part A is 12.5.
Yeah, I got 12.5.
12.5 and the average speed of the particle during the time this 12.5 meter per second. This was answer of A part. And please solve B part.
Okay, I'm doing that right now. Um, 25?
25, correct? And that is V equals to ds by dt.
Yeah.
And this equals to d upon dt of s. And this is 2.5 t square. And this is 2.5 into differentiation will be 2t. And this will be 5t. And our answer is required for t equal to 5 seconds. So that's why 5 into 5 equals 25 meter per second, right?
Yeah.
Okay. And next question, can I change this page?
One second. Yeah, you can.
Okay. Suppose I have a question like this. Um, Suppose x equals to a kt cube plus bt square plus ct plus d, right?
Okay.
Here a equals to 1, b equals to 4, c equals to minus 2, and d equals to 5, right?
Yes.
Our question is find the average acceleration. Find the average acceleration.
And what is x? Is x
X is
distance?
position. X is position. During the interval. During the
Wait,
interval.
so I didn't hear you. What is x again?
Just a second. I am describing. Uh, Interval t equal to 0 to t equal to 4. So t equals to. Here, this is a equals to 1, b equals to 4, c equals to minus 2, and d equals to 5. These are constants, right? Here x is position. Here x is position of particle, and t represents time. And I have to find average acceleration. A average.
So is
A
it safe for
average.
me to assume that x is displacement?
Okay. Yes, yes. You may imagine x is displacement.
Okay.
You may also understand displacement as a function of time. Displacement as a function of time. Displacement as a function of time. Right? This
Yeah.
is. Can you do this, Mohammed?
Yeah, yeah, I can do it. Is it 20?
Please tell me.
Okay, so basically, first I differentiated. Okay, so first I got, because you told me what A, B, C, and D are, so I got x is equal to t cubed plus 4t squared minus 2t plus 5.
Okay.
Then
Then.
I differentiated it to find the instantaneous velocity. So I got dx by dt is equal to 3t squared plus 8t minus 2.
Okay. Then.
Then I found the final and initial velocity. So the final velocity is dx by dt, but you sub in the value of t is equal to 4, which you get
Okay.
78 for
Yes,
final
sir.
velocity. And for initial velocity, you do the same thing, but with t is equal to 0, and you get minus 2.
Okay.
So the acceleration average is final velocity minus initial velocity over final time minus initial time. So 78 minus minus 2, which is plus 2. So 80 over 4 minus 0, which is 4. So 80 over 4 is 20.
Okay. Very good. This one, right?
Yeah,
So
yeah.
v at t equals to 4 minus v at t equals to 0 by 4 minus 0, right?
Yes, yes.
Okay. 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 Meeting next time, right? And
Okay.
I will solve this type question. Say this is proving of s equals to u plus v into t by 2, v equal to u plus 80, and graph to be able to draw the interpret displacement time, velocity time, and 80 graphs. I will
Okay.
discuss these graphs and these equations in the next class, right?
Okay.